Hello, my name is Mr. Biscayes. Everybody calls me Mr. B. I am the middle school engineering teacher at Hayfield Secondary School. This video is to teach students an introduction to designing a rocket in white box learning. You are seeing the interface right now. Notice we are in the engineering tab. At this point, the student should have already gone through the research section, completed quizzes and worksheets. But I'm just going to demonstrate the design part of it. Let's start off with a new design. I always like to make sure I have a fresh, clean design. So I go to that Fire Manager symbol right over here. I'm going to click New. I do have to give it a name, and it's just going to be Mr. B, period 7, demo, demo 2. How about that? Name it whatever you want. The first thing we're going to do is let's take a look at our rocket design model. Click the view symbol, which is that eye. And this is a default rocket. This is what Whitebox gives you. Down at the bottom, you will see this toolbar. I know it's partly cut off by the video recording software, but this first one is rotate, which is allows you to rotate it around in 3D space. This is the default rocket. Now, is this rocket going to be good enough or not? Well, let's go to the outputs. Let's first check the specification. So I go to outputs and specification. And this default rocket, okay, is not in spec. Anything that's in red here means it's not in spec. You cannot compete with this rocket. So I've got to go back to engineering, and I'm just going to work down this list. Nose length is the first thing. You can see it is about 5 millimeters, 5.69 millimeters, too long. And let's go after that. Engineering. Nose length. Now, a lot of kids go to nose here, and they're like, I don't see anything there. Well, actually, they're saying that this length up here, it's not part of the bottle, is too long. Actually, you have to go to the cone tube, sorry. And that's what's too long right here. When you want to get rid of one of these menus, I'm just clicking done. Okay. One about 90. It could be like 194 if I wanted to keep it maximum length. And so I believe I've shortened the rocket. You should have seen it shortened in the real time here in the model as well. If we go back over and check our spec, sure enough, the length is within spec now. We're at 223, 228 is the max. Tip, you want to keep your rocket long. Longer rockets are more stable than short rockets. So I'm going to keep it on the long side. Design total height, still a little bit too long. And we have a parachute. It doesn't like the parachute. So let's take a look there. Design total height. Let's go down to recovery. That's where a parachute is. And we have two recovery systems. One is the parachute. The other one is called backslider, where it just kind of comes down sideways and wobbles back to earth. So we're going to go ahead and use that one. And that should have fixed that problem. Okay, that's gone. Design height is too tall. It says it's 55.3, and we're at 55.39. So it's still a little bit too tall. We got this nose length. There's a restriction on the nose length, but then there's a restriction on the overall length. Notice there's a change of units. So we're talking millimeters here, centimeters here. All right. So this is still a little bit too tall. So I'm going to go back to that tube and shave a little bit off of it, taking it down to 185. When I do that, it should clear up. See, everything is in spec now. So technically, this rocket is in spec. And I can save it into competition. And I go to the file manager, save and enter competition. And now I can go to the competition and my rocket will appear along with all the other rockets. I can do all designs. I can do the ones that have just entered the competition, which means they're staged, they haven't flown at all, or I can just say my designs. And you can compete against any rocket you want. It doesn't matter. All rockets. Come on. Oh, I got to get rid of my designs. All designs. There we go. Okay. So here are a couple of stage rockets. Mine will be one of them. Actually, and so I'm just going to go ahead and play the competition. I'm playing it because I'm going to turn a little bit loud, I think. Okay. That was actually my rocket on the right, and I lost. But this is where it gets really important. We need to go ahead and look at, they gave you some high level stuff. Um, my mass was a little bit greater than the other rocket. The drag was actually a little bit better. And what else? Static margin on both rockets is really bad. Static margin is really important. We'll get into that more a little bit later, but what it has to do with is the stability of the rocket. So let me go back and try to clean things up a little bit here. And it's pretty easy to do. So I got some points. You can see I got a few points up here. All right, got some points for my rocket, but it's not a very good rocket. I should be getting like 70 points at least. Okay, so how can we make it? That's after school bell. How can we make it better? Well, right down in here, they tell you the things you really want to pay attention to: mass, thrust, drag, stability. Okay, so I already talked about the drag. So let's see what we can do with that. Drag coefficient is right here. That's really what we're looking at. That's the magic number. So it's 0.4574. We can make that better. If we click on the view symbol here, it actually does a color analysis. Green is excellent. Red is the worst. And colors between green and red are various degrees of not so great. You can see all these gold colors. That's not so great, because imagine the wind as it's slicing through the wind's hitting that very steep transition cone right there is what that's called, and creating a lot of drag. So if we go to this code transition, I want you to keep an eye on this drag coefficient down here. I'm going to make this cone as long as I possibly can to make it less steep. Make that air does not like to change directions. If the air is changing directions, there's drag. So I'm going to go up here and I'm going to max this thing out. Boom. Now, it did change color a little bit, if you can notice it. Let me close this. That's the tube. We're done with that. But notice how far down our drag went. It was 0.4 something. Now it's down in the 0.3s. That helped a lot, even though the color didn't change a little bit. What are some other things we can do? All right. Well, these fins, that's the default fin. Let's take a look at our fins. Let's be a little more creative with our fins. Those fins are very, very small. That means our stability is probably not very good. The way you change the fin designs is you just hold down on one of these dots. Oh, it's rotating at the same time. Don't worry about that. And I'm changing the fin design to be longer, sleeker, and have more control. I'm going to slide this down a little bit too. So I think I can, let me just turn this off real quick. Come on. Oh, I got to turn off there. Okay. I'm going to turn off all these other views. So we're just looking at the fin. Okay. So here's the fin right here. It's more aerodynamic. It's sloped at the top. That's a good thing. And it goes down a little bit longer. We should get more stability out of that. Stability is very important. That factors into that static margin. Notice this red area right here. We need to stay out of it. If I design my fin into the red area, that means it's going to hit the launcher where we try to connect it on. So stay out of that area. And let me slide that up a little bit. And what's our stability number look like now? That was that static margin, okay? So I should be all in spec on everything, but because that's the first thing we did. New design, get it in spec. Now make your in spec rocket better. So that's what we're focused on, making it better. We made the transition cone longer, it dropped drag, and now we're trying to improve some other things. Fins will help a lot. So if we look at stability right here, our stability is still pretty lousy, all right? Without going into a lot of detail, because that's could take a whole video, is the static margin is a relationship between their center of gravity and the what they call center of pressure. And let me get rid of these charts. I don't want that. Yes, I do. Sorry. Let me get rid of the fin. We're done with the fins, okay? I'm going to close that up. Let me close up all these. So what it's telling us right now is, and you'll see this if I can. There we go. You see these dots right here? The silver one is center of gravity. The red and black one is center of pressure. Center of pressure needs to be way down here. Center of gravity needs to be up more towards the nose, almost right at the base of this cone. Center of gravity is determined by weight. It means our rocket is too light. I know that sounds counterintuitive, but it's a little bit too light. And our fins aren't quite big enough because the center of pressure is really the center of the surface area of the whole rocket. When we added this big cone up here, we added a lot of surface area up here, but we didn't add it down here. So let's add a little weight to the nose first. So let's go to the nose. And we can add some clay. I'm going to add a couple of grams. A couple of grams is actually a lot for a bottle rocket. And so you notice you saw center of gravity start to move up. So let me add a lot more clay than that, 7 grams. Now, notice my static margin is positive now, and it's 17.1. We want that number to be as big as possible. So it's the red dot is the center of your surface area, which they call the center of pressure. The silver dot is the center of gravity, which we should have more up here a little bit. It also has something to do with our bottle. There's all kinds of changes we can make. This should be in spec. Oh, it got a little too heavy. Added a little too much clay. See, I'm 0.8 grams over. So let me get rid of some of that clay. So I'm going to do 6.2 would work. Lost a little static margin there, but at least it's still positive. And I'm in spec. We're going to put this one in the competition. Save and enter competition. Go to the competition. Reset. Pick my rocket and somebody else's. It could be anybody. I'm going to pick the one that's really good. I think it's really good. I believe I still lost, so I still have work to do. And you can also look at the other rocket as well. And so their static margin is higher, their weight is less, so on and so forth. bottom line is there is no magic potion here. It's all these different parts of the rocket interacting and it's trade-offs. I reduce my drag by making that great big cone. Well, and it messes up my static margin and it probably added some weight. So I added some clay to improve my static margin. Now my weight is more. Okay. And there is one thing. Oh, this other one's out of spec. So I won anyway on a technicality. Here's one other thing I want you to look at real quick. And then I promise I'm done. If we look at we're using a 2-liter bottle. We have to use a 2-liter bottle. If you remember back in the research section, we're always encouraging kids to our students go back to the research section. How can we maximize our thrust? Maximum thrust is good. And we're looking through here. It's a function of the amount of water in the rocket and the amount of pressure. Okay? Well, here are 2-liter bottles. These are charts these are all 1 liter, but here's 2-liter bottles. All right. And we're at 65 PSI. So there's not one for 65, but there's one for 60. And this is showing our velocity. And right here is about where it maxes out. See what I'm saying? Right about here. And if I come down, that's right around 0.6 liters, right around 0.6 is where I'm going to get my maximum velocity. How much water is in my rocket? Only 0.4. So I'm really missing out. I'm way back here on the curve, down at 0.4. I'm missing out on some velocity. So I'm going to go back here and I'm going to do the 0.6. And a little bit of water makes a big difference, honest. And so I'm done there. I'm going to save it into competition. Now, what I'm going to do is a shortcut. I'm going to reset the competition. Can I still do that? I'm going to pick my rocket. And I'm just going to compete against myself for speed purposes. And I can say skip the animation. I don't need the crowd cheering. I just want to see what happened. Okay, I'm in spec and my static margin is still pretty good. My velocity went up a little bit. I think I was at 40 before. I'm at 43 now. So changing the water helped. I am in spec. I have a good rocket. So that's it. There's a whole bunch of things you can mess around with. We're using a Coke bottle. How does a Pepsi bottle work? Does it work better? Remember, it has to be 2 liters in this level, okay? Can I take some of that clay away? Can I make my fins bigger? Can I add a fin? Can I go from 3 fins to 4 fins? Is that transition cone perhaps a little bit too big? Did I get carried away with that drag? And it wasn't worth the extra weight I added. All these different things. Now I just hope that you see how these different things affect your rocket. And now you can start experimenting with different combinations. Okay. And I got the static margin one still on the screen. So I'll just show you something. If I make this transition cone shorter, okay, it's going to move, or it's going to change my stability a little bit for the better, probably. All right, so that's how you do a rocket. That's how you get one in spec really quick. And then I showed you some of the customizations. That is it. I'm trying to keep this short. It's already 19 minutes, but I hope you found this useful. Have a good evening, and I will see you in the lab.